We've introduced the expected Sarsa control algorithm. Now it's time to see it in action. By the end of this video, you'll be able to describe expected Sarsa's behavior in an example MDP, and empirically compare expected Sarsa and Sarsa. We will use the cliff walk environment again, so we can talk about Sarsa, Q-learning, and expected Sarsa all at once. Let's recap. This environment is an undiscounted, episodic grid world with a cliff on the bottom edge. Moving into the cliff moves the agent back to the start with a reward of -100. Otherwise, the reward is -1 on each time step. Sarsa performed better than Q-learning on this domain because Sarsa's policy accounted for its own exploration. Today, we'll compare expected Sarsa to Sarsa with an epsilon of 0.1. This plot was created by testing each agent with different values of the step size parameter alpha. We did 100 episodes and averaged everything over 50,000 independent runs. The y-axis shows the average return per episode, and the x-axis shows the step size values. Sarsa's performance increases with larger step size values, but only up to a point. The best alpha value for Sarsa here was 0.9. Expected Sarsa outperforms Sarsa for almost all values of alpha. Expected Sarsa is able to use larger alpha values more effectively. This is because it explicitly averages over the randomness due to its own policy. This environment is deterministic, so there are no other sources of randomness to account for. This means expected Sarsa's updates are deterministic for a given state and action. Sarsa's updates, on the other hand, can vary significantly depending on the next action. Now let's look at the average return per episode after 100,000 episodes. At this point, each algorithm has learned everything it's going to learn. Expected Sarsa's long-term behavior is unaffected by alpha. Its updates are deterministic in this example. Therefore, the step size only determines how quickly the estimates approach their target values. Sarsa behaves quite differently here. It even fails to converge for larger values of alpha. As alpha decreases, Sarsa's long-run performance approaches expected Sarsa's. In this video, we've seen that expected Sarsa was able to quickly learn a good policy in the cliff world, and that expected Sarsa is more robust than Sarsa to large step sizes.